Hello students, in this quick little video I want to show you how to do some regression analysis which you'll need for your fourth computer assignment. So in your fourth computer assignment I'm going to be using a different data, but these are the items that you will be asked to find and to calculate. Let's bring over my Excel file, take that over there. So we're working with So I'm going to show you how to do it using this Excel file. So this is an Excel file for 22 retail stores with their retail sales going against household income in these in the neighborhoods of these 22 retail stores. And we're trying to see if there is association or relationship between household income and retail sales. So in your computer assignment, using different data, but the process is going to be the same. So the first thing you need to do is, under the Data tab, actually the first thing we're going to do is going to highlight the data. This is something just to help us understand possible trend between the data. We're going to do a scatter diagram, and there it is. Household income on the x-axis increases. We can see retail sales increasing as well, and there is a definite upward trend. So let's get rid of that. Let's go to the Data tab under the Data Analysis, and you want to scroll down until you get to Regression. Click OK. The Y range is what we are trying to predict. We're trying to predict or measure the association for retail sales using household income. Make sure labels are, you've checked off labels, and then hit OK. And it takes you to a new worksheet. I'm going to go to this one where I've just made it a little bigger and things stand out a little bit more. So the first thing we want to do is determine the slope and intercept. I'm going to put what I'm finding up here, slope and intercept. The slope is this value down here. Let's color code that in. You don't need to do that. Just going to show you where I'm getting these values from. And the intercept is this value there. So different color, there's our intercept. So there are functions in Excel that we can use to find the slope and intercept, but the regression analysis tool does this for us. So the second part is to develop the regression equation. Regression equation is that y equals the intercept, which is 559.46, plus the slope times x. Or in this example, we have retail sales is going to equal the intercept, 559.46, plus the slope times household income. Pearson correlation. Pearson correlation is this value right in here. Let's color code that. Let's put that over there. Remember, Pearson is a measure of correlation between two variables. In this case, measures from -1 to +1. So this is showing that it is a strong association correlation between the two variables, household income and retail sales. Keep in mind that Pearson can be negative, but we know it's positive because our slope down here in yellow is positive. How much of the variability of y, or retail sales, is explained by the variation in x? So this is called the coefficient of determination. The goodness of fit. The measurement of the variability of one variable as expressed in the other variable. So let's color code that a little bit. Let's just put that back there. Hopefully I don't run out of colors. Oops. Don't want that colored. There we go. Make this a little bigger. And it is going to be this value here. And generally it is expressed as a percentage. Remember that the coefficient of variation is Pearson squared, and we can see that if we were to go to a different spot, go equals, click on Pearson, and square that value, make it into a percentage, we get that same value. So that's how we find the coefficient of determination. What we've done so far really has no bearing or relevance, in a way, if we find that there is no significant relationship between the two variables here. So what we're measuring, again, is that the null hypotheses would be back up a little bit. I'm going to write the null hypotheses, the correct one, using our symbols here. The correct null hypothesis is that the slope equals 0. And we are going to test to see the opposite. On your lab, on your computer assignment, you don't need to write down the null and alternative hypotheses. I'm just doing that to show you what it would be. Okay. There is our null and alternative hypotheses. There it is. Actually, it's B1 instead of just B, but you know what I mean. Okay, so it's a two-tailed test. So our decision is going to be based on the p-value. Reject the null hypothesis if the p-value is less than alpha. That level of significance, that risk of making that type 1 mistake. Alpha in the question is stated to be 5%, and we're going to reject our null decision if the p-value is less than alpha. I'm going to write down here, and once again, you don't need to do this, what the results of the decision would be. So if we make the decision to reject the null hypotheses, basically it is saying that there is a significant relationship, correlation, association between the two variables. In this case, retail sales and household income. And of course, if we fail to reject the null hypotheses, we can't say that there is a significant relationship. So keep that in mind. The decision process, comparing p-value with alpha, and what the decision actually means when we reject the null hypotheses. So the p-value, what we need here is the p-value, or significance f. Basically, the p-value is found right here. It's a really small value. Let's color code that. I haven't used a nice screen before. There we go. So if you don't understand scientific notation, what you can do is you'll have to, let's do the miss cell here. Extend the cell a little bit. Just change the format to number and increase it. Basically, there's going to be like 12, 11 zeros in there. So this means that it's a really, really small number. P-value is small. How we define small is by comparing it to alpha. Alpha is 5% or 0.05. Therefore, our decision is going to be reject the null hypothesis. So the second part of this is basically the decision. Is there a significant relationship between x and y? Explain your answer. Alpha is 5%. We are basically saying reject the null hypotheses because the p-value is less than alpha, is less than 5%. The p-value shows us the strength of that decision, which is, if you look at the odds of this occurring, it's going to be whatever that number turns out to be. That's a huge number. 1 in 4.6, slightly more than a trillion. So basically the chances of this happening naturally would basically not really be probable. Is there a significant relationship? Yes, there is, because the p-value is less than alpha. So let's put up here yes. And because we are rejecting a null hypothesis because the p-value is less than alpha. If salary, one thing we can do with this, because there is a significant relationship, we can then predict possible values here. So we could say, so the question states, let's go back to that. If household income equals 60,000, what would be the expected, I should say, retail sales? So if we build a store in a neighborhood with a household income of 60,000, what would be our expected sales? Let's do that first. Basically, we're going to go back into this regression equation here and substitute in 60,000 for x. So we can do that by going intercept, click on the value of intercept if you want, plus slope times 60,000. And that would be our expected retail sales. Oops. The second part of this question states, would you use this regression equation? Why or why not? We would use this because there is a high association as measured by the Pearson correlation coefficient and by the size of the p-value and our decision to reject the null hypotheses, which means that there is a significant relationship between the two variables. So we are confident in using household income to predict and determine retail sales. If the p-value, if our decision were opposite, if the p-value was larger than alpha, we would not want to use x to determine the variable y, because there is not that significant relationship or association. So from this, you should be able to go back. You go into your the Computer 4 assignment and carry out this process using the Data tab and Data Analysis, basically clearly labeling your answers here, and make sure you answer all of the questions.